Hello, my name is Jeray Borges, and in this video we are going to talk about how to configure TLS to secure the traffic of WildFly microservices running on Openshift. The idea is to go through a practical example where we are going to configure to protect the external traffic using one-way TLS and the internal traffic using mutual TLS. I hope you find this video useful, and let's start. Before going with the practical example, let's talk a bit about what we can use in Kubernetes or Openshift to protect the traffic. Probably the best option will be to use a service mesh, for example Istio, which is an open source service mesh. And with the service mesh, a dedicated infrastructure layer will implement the security for you. So your application will be agnostic regarding how the communication is secured behind the scenes. It means you can continue using HTTP endpoints, and this communication will be secured by service mesh. If you don't have a service mesh available in your cluster, you could, for example, use application level security. In this case, your application will be in charge of the security of the endpoints. So you have to create the private keys, public keys, certificates, make them available to your application. If you're working on Openshift, one way to create all this TLS material is by using the Openshift Service CI controller. However, as far as I know, the Openshift CI controller is not able to work out of the box with the key stores and true stores. So the TLS material created by the Service CI controller needs to be converted in the default format used by our Java applications. An alternative to the Openshift CI controller is the Cert Manager with Cert Manager operator, which allows you to create key stores and true store out of the box. In this demo, we are going to implement application level security, and we are going to create and deploy our certificates manually. The idea is you can use as a foundation to later use Cert Manager operator or Openshift Service CI controller to create all the TLS material in an automatic way. Okay, this is the scenario we are going to work on. I have already deployed everything in my Openshift cluster, a cluster from Red Hat Developer Sandbox. I have deployed two WildFly microservices, the one which acts as a front end and the second as the backend. The front end access to the backend by using microprofile REST client, and the front end is exposed to the external wall by using a route. Since I have used the WildFly Helm chart to deploy everything, I got by default a route configured with the TLS termination. We will talk more about different TLS termination later. However, HTLS means that the traffic will be encrypted from my local computer to the route by using the cluster certificates. However, the communication between the route and the first microservice is not encrypted at all, and also between both microservices. This configuration could be perfectly fine. However, if you are running on a zero trust environment, you will also need to configure to secure the communication between the route and the front end, and also between both microservices. This is what we are going to do here. First of all, let's take a quick look at the code to get familiar about the changes we need to apply. This application is available on GitHub, and here we have the two microservices. The front end is just a RESTful web service. Here on the listening on the greetings URL. Okay, and if you access to greetings backend, this web service will invoke endpoint of the backend using microprofile REST client. Probably the relevant configuration here will be the Helm chart configuration, where we have specified the URL of the backend. Notice that we are using an unsecure connection, and this is the name of the web service, the name of the Openshift service, which is in front of the backend pods. This web service, this OpenShift service will act as a load balancer between all the backend replicas. On the backend side, there is nothing special, just to mention that we have the same RESTful web service here. So okay, let's check that everything is up and running. So if we access to the front end from my local computer using the route, I will get a response on the 8080 local port. It means an unsecure endpoint, unsecure port. However, if we access to the backend from the backend from the front end, I get a response also on the 8080 port, which is an unsecure one. So the idea now is to configure TLS, one-way TLS, to secure this port and to secure the communication between my local computer and the front-end microservice. To protect the traffic from my local computer to the WildFly front-end microservice, we need to enable the HTTPS endpoint on the WildFly instance. So we need to configure Electron, Undertow, and generate all the certificates used to secure the communication. I have already prepared everything, so let's take a quick look about what I have modified. On this folder, I have created a key store that will contain the public key, private key, and self-signed certificate that we are going to use to encrypt the communication. I used the key tool command to do that. And then this key store will be mounted in our pod by using a secret. Okay, I have also created that secret that will include the key store there. To configure Electron Undertow, I have created a CLI file. This is just a simple regular file where we can add the management operations required to configure our WildFly. Here I am configuring Electron and Undertow to enable the HTTPS endpoint. And probably the relevant part here is there are a couple of environment variables that will be injected at runtime when the pod is started. The values of these environment variables are configured in the Helm chart. To apply this configuration, we also need to modify the WildFly Maven plugin and instruct that we have this CLI file and we want to apply the configuration here when the WildFly instance is being provisioned in Openshift. And the last point to review is the Helm chart. Here I have enabled the TLS, which means that at the end I am going to this Helm chart is going to create a OpenShift service exposing the default HTTPS endpoint. I also modified the route to use pass-through instead of the default one, which was Edge. With pass-through, the communication, the request when the request arrives to the route, it will be passed directly to the target entity, target pod in this case. Without the route is not going to apply any modification on the request. There is a third option here, which is encrypt, and that could be useful if you want to keep different certificates in the route. For example, the external communication from my computer to the route will be encrypted with one certificate, and then the route itself will encrypt again the payload using a different certificate. So you can manage the communication by using two certificates, one for the external clients and one for the internal pods. Okay, so the last point of the configuration is here that I am mounting in a volume the secret that contains the key store and configure the environment variables that will be required to start the WildFly instance. So having said that, let's kick off. Let's upgrade the Helm chart and start a new build, so I can get all the changes applied in my Openshift cluster. Let's wait until that is done and all the pods are ready. Okay, we have already our front-end microservice running with the new configuration. So right now we should have a secured endpoint on this microservice. So let's check it. We could notice that right now I have to accept the self-signed certificate with -K. And okay, right. So we have here the response right now comes from the default HTTPS endpoint. So we are using right now our communication from my local computer to the front end is secure. If we access to the back end from the front end, we can see it's still on the 8080 port. So let's now configure the mutual TLS between both microservices, so we can ensure secure this communication. Okay, so now we are going to configure the mutual TLS between the front end and the back end. On the back end, we are going to configure the HTTPS endpoint, and on the front end, we will modify the microprofile REST client to use a new key store and true stores. Okay, so there are a lot of steps or commands to prepare all the TLS material. Everything is on the wrapper file, all the commands I used, so you can check them there. And yeah, now let's review what I have done here. On the TLS folder on the backend side, I have created a new key store and extracted from this key store the backend self-signed certificate. This certificate is then imported into the front-end true stores here. And we have to do the same for the front-end certificate. We extract the self-signed certificate here from the key store and import it on the backend true stores. It means the communication between both microservices will be only allowed for the microservice they trust on, using the certificates they have in the true stores. Okay, so okay, on the backend side, we also need to configure the HTTPS endpoint. This is the similar configuration we did for the front end in the previous step. However, now we have configured a true store and true store manager. The same, we need to apply this config file. We have also modified the WildFly mapping plugin, and the changes on the Helm chart are the following ones. Enable TLS to create a secure Openshift, to create a service that exposes the default HTTPS endpoint of the backend, and the similar configuration we did for the front end previously. We mount the backend secret with all the TLS material and prepare the environment variables required at runtime to start this WildFly instance with Electron and Undertow configured. On the front-end side, the changes are on the Helm chart, because we need to configure the client side of this mutual TLS communication. The client side is the microprofile REST client. So we have also imported the secret with all the TLS material here and mounted a volume, and from this secret we are configuring the microprofile REST client URL. Right now is using HTTPS and using the Openshift service that exposes the HTTPS endpoint port on the backend side. We also have configured the true store and key store to enable the mutual TLS connection. Okay, so this is all. Now we need to push up the changes in our branch and upgrade the Helm charts and kick off another set of builds, so we can get the um, the new microservices with the current configuration. Let's do that and wait until they are ready. Okay, our microservices are already running, so now it's time to verify that both communications are using secured endpoints. First of all, we access to the front end, and we are still using the secured endpoint. And also, if we access to the backend via the backend from the front end, the backend is now giving a response using a secured endpoint. So it means that the WildFly TLS connection is working and all the traffic is secure from my local computer to the front end and to the microservices on my cluster. Also notice that the backend is not going to accept any connections for any other microservice if they don't have the correct certificates. Before to concluding, let's comment a side point about secret usages in Kubernetes or Openshift. You also need to secure the access of those secrets. Probably you will need also to encrypt the information you are storing then. Just because they are secrets are not secret out of the box. So in this scenario, for example, if anyone take access to the certificates or the TLS material, it will be able to connect, for example, to our backend and do malicious things. So this is important to remember that when you are using secret, you should also enable RBAC and configure users and protect the access of those secrets. Okay, having said that, this is all. I hope you have enjoyed the video. If you like it, subscribe to the WildFly YouTube channel. Yeah, thanks for watching and have a nice day.